a software development.
Let me see. Yeah, I think we are live. Yes. Let me check. Yes. Let me see. Hello, everyone. Good morning. Good afternoon, wherever you are. We ask, wait for folks to join. Okay. Hi, everyone. Good morning. Prachi has also joined. Okay.
Good morning.
Check on LinkedIn. We are live on both YouTube and LinkedIn. So let me see once. Yeah. So you can watch us live on YouTube and on LinkedIn, both simultaneously. So if there's any glitch on the YouTube side, switch over to LinkedIn. Okay. Yes. LinkedIn, I can see Prachi clearly and myself too.
Live on both YouTube.
One second.
Yeah. You can watch us live on YouTube and on LinkedIn, both.
Yeah. Okay. Our voice is loud and clear. Satish, Dikshant, everyone. You can hear us loud and clear? Okay. So good morning, everyone. Welcome back again to Analytics Talent. So today is a very, very important day. So me and Prachi, we are formally introducing you to a very, very important course of mastering PySpark with Databricks. We'll go first. I'll explain you the entire course, how it is. So today is a complete kickoff. So Prachi will be taking you the complete journey. What is the syllabus and everything we'll be talking about. So just be with us. You don't have to do anything. Just listen to what Prachi will be teaching you. It's just a kickoff class to give you an overview, the flavor, what PySpark is all about, and how it is helpful for your data engineering industry and why one should study it, right? So let me share my screen quickly and then we'll go from here. Yeah. My screen is visible to all. Yeah. Right. So this is the course which you are seeing right on my screen. You can go to Analytics with Anand and then you can go to the course section and you can see this Mastering PySparks with Data screen, right? Price also you can see it on the screen which is visible for you. Now this entire course will be a 3-month completely live every Saturday, Sunday from 12, same, we are launching at 12 p.m. and same you'll be having from 12 p.m. to 2 p.m. every Saturday and Sunday. Now, what is the prerequisite before enrolling for this course, right? Before you enroll for this course, your Python, you should be having a basic proficiency in Python programming, very basic. If you have an understanding how Python works, how NumPy and Pandas works, well enough. That's enough for me. No prior knowledge of any big data technology is required. Just basic proficiency in Python programming, I need it, right? Now, those who are in the data analytics course, those who wants to switch into the data analytics career, This is not the requirement, right? Nowhere in any interview or anywhere down the line you will be using PySpark. This is not required for a data analytics role. This is typically required if you are planning to go for a data engineering role, if you are into the data engineering, or if you are into the data analytics and having some 3 to 5 years of experience, like me, Prachi, XYZ, whosoever is watching us live. If you are having that 3 to 5 years of experience and you want to convert that experience into the data engineering, then this is the right course for you. After Python, if anything, if you want to learn, this is the course for you. Even for the data analytics, if you want to learn for your purpose so that you can use this further down the line later on, because Databricks is booming, right? So PySpark is the, where you will be writing on Databricks completely. So I would urge, even if you are a data analytics, even if you are well versed with Python, if you want to go ahead with it, PySpark, you have to go ahead. But for data engineering, PySpark is must, right? See, the first point only it says, target audience. This course is ideal for data analysts and data engineers looking to enhance their big data capabilities. Machine learning practitioner, professional, transiting into data engineering fields. I told you. So if you are having a minimum 3 years of experience, right? And if you want to switch to the data engineering role, better package, better work-life balance in company, PySpark is the tool. After Python, any programming language, if you want to master it, the PySpark is the one, right? So there will be complete 48 hours of live instructor-led session. Day-wise agenda also, I'm showcasing it to you. See this. Entire syllabus will be covering in, right? Day-wise, this today is 2nd March. Ideally, we should have kicked it yesterday. But yesterday, we had some technical issues, right? There was a problem. That's why we couldn't take your charge. So every Saturday, Sunday, you see this. Your class will happen till 18th May. You can add one more week extra, 1 day extra, because we have not done the yesterday, right? So this is a 3 months, ideally, course, completely live, which you can see right on the screen, where we'll be discussing very, very in detail, in depth, Kafka, CDC, all this will be covering it in detail. Right, the capstone project which we'll be talking about, that will be completing all the Spark architecture completely on the Databricks, right? So this is the course which I would ask all of you to go through it, right? We'll start from the complete basics. If you don't know XYZ of Spark, don't worry, Prachi is there to help you, right? We'll do hands-on coding, using PySpark on Databricks. Today also, she might be showing you few here and there code, which she'll be writing and showcasing you how there's a difference in PySpark and Python. We'll be talking about real-time data streaming, machine learning integration, real-world data sets for hands-on projects, collaborating coding with Databricks. The entire PySpark, we will be doing it on Databricks, right? So what we'll be learning, what we can expect from this course. So we can expect about first of all, the architecture. You need to understand that the basic functionality, which we will discuss. Then we'll talk about Spark SQL, what are the data frames, which is available in Python also. Then RDD essentials. Then we'll talk about data wrangling and Pandas API on Spark. And we'll build all this ETL pipeline and machine learning model with MLab and Kafka integration. So this entire thing we'll be discussing in the complete PySpark course, which we are kickstarting from today. So you can buy from the app, you can go visit the website, and you can buy from there itself. Right? Feel free to reach out to me, Prachi, anywhere. We have our LinkedIn anywhere. If you type Analytics with Anand on Google, you will get it directly. Now, let me come back quickly, before Prachi begins, let me come back quickly to the syllabus. So this is the entire syllabus which you see. So we'll start with the introduction. We'll talk about architecture. What is Spark SQL? Then we'll set up, we'll configure the entire Spark, how you can configure Spark with respect to Databricks, completely cloud. No, no any infrastructure is required for this. Right, we'll talk about RDD, then we'll talk about all the semi-structured and structured data, how we can handle it. Data wrangling, we'll talk about the ETL pipeline and Spark streaming with Python. See, that's why I've told you. Basic Python is required for this, right? Basic Python is required for this. Now, the bumper course which you get along with this PySpark is when you enroll in this course, automatically entire Prachi's Python session is embedded in this. If you see the content of PySpark, entire Python I have given you right from the last 2 years, whatever we have discussed. If you see this August 2024 cohort, right, entire live sections, everything, whatever Prachi has discussed, right from I'm giving you all this recording from 2nd March 2024 onwards still. Right, last 1 year entire data and the latest batch also which Prachi has taken for Python, that live session also you'll be having it. Entire thing I have given from zero to hero, master Python for data analyst, so that Later on, you don't have to come and ask me. I'm not well versed with Python, how to do it. Python course is embedded in this, absolutely free of cost. So those who wants to join this PySpark, Python course is embedded in it. If you go to my website, you will see a different Python course here. Let me show it to you. Let me show it to you quickly. That is taken care by Prachi only. Right. So if you see here, see this. Entire this Python course, I'm giving it for free completely. Right? Even the new batch of Python, which will be coming like that, you can attend absolutely free of cost. Right? So both PySpark and Python, you can master it clearly. Right? So that's the beauty of this course. Learn PySpark from the scratch, and Python already I am giving it to you. Right? Already Python is embedded in it. So any doubt, anytime you have, Prachi is there to help you all. So both Python and PySpark, you can master it in this. That's the beauty. Right? So as I was talking about this entire architecture, Park streaming, ETL pipeline, optimization techniques, machine learning with PySpark, and all the use case and the project which we'll be talking about will be about the CDC and how the replication we are going to do this. So entire this Spark syllabus will cover in 3 months, completely live, 48 hours of session schedule also I have given you, syllabus also given you. So if you go to the description of this lecture video, you will have the full-fledged description, and whatever the files which Prachi will be sharing you in today's class, already I have given that link. If you go to this branch, PySpark, entire thing I have given you, right? End-to-end project also I'll upload it, data sets, code files, and document, whichever Prachi gonna teach in today's class, everything is here, and that is there in the link of this description. Right? So this is how PySpark should be. So first of all, you have to well versed with Python in order to excel this. Basic of Python should be there. Even if you have not mastered the complete Python, no worries. Right? At least basic understanding of Python, if you have well and good, you can start ahead with this course. Right? That's all from my side. Anyone has any question, any doubt, feel free to throw to Prachi once she will be starting the session. That's all from my side. Over to you, Prachi. Yeah.
Thank you so much, Anand. So hello everyone, I am Prachi. So basically, I am a data engineer at ThinkBiz Technology. I hold 3.5 years of experience, and along with that, I am also teaching Python, giving trainings in Python, SQL, and all. Okay, so this is all about me, and let's start the introduction with the Spark. So I'm sharing my screen. Uh, Please confirm my screen is visible or not. Anand, is it visible?
Yeah, I can see.
Okay, a second. Okay. So today my agenda is to go through with this what is Spark, what problem actually Spark do solve, okay, and everything related to Spark, like the definition itself includes lots of things you need to understand from the scratch. What is compute engine? What is parallel processing? What is compute cluster? Right? Why we need Spark? Then Hadoop versus Spark. Actually, the before the Spark, there was a Hadoop. Okay, so Spark has replaced the Hadoop? The problem Spark has solved and Hadoop don't solve, right? So everything we will understand. Then why PySpark comes? Like we have a pandas already there, right? So in terms of pandas, why we need PySpark? Okay, then we'll see the overview of Databricks UI. Okay, we'll all do this coding part in the community edition of Databricks. All right, and we'll see a little bit about code, how we write code in Databricks, how cluster works there, little understanding. All right. So let's start from the. Okay. So what is Apache Spark? Okay. So first of all, let's see. So Spark is a unified computing engine. Okay. And a set of libraries. Now, what is unified? Okay. So unified means everything is on one place. For example, For example, like your data scientist, data analyst, and data engineers, right? All can use same platform. right? For their data transformation, data modeling, and all processing. Okay, but why I am saying that it is unified? Okay, so what data engineers basically do? They basically build a pipeline and process the data, and data analysts use that processed data for their modeling and for the uh, report building, for KPIs, right? And what data scientists do? So using this data, they predict the future, build the models and everything, right? But they are using the same thing. So this is called unified. Okay. So I hope you understood the meaning of unified. Okay. Now come to the set of libraries. So what libraries do? Basically, libraries means a predefined function called predefined function. There are some written by some people, some persons, few libraries, like you can say pandas is there. So same as for the Spark, there is a predefined libraries are there. Okay. Now come to the parallel processing. Okay. So parallel processing means if you are doing something. Okay. So basically Spark works as a work. We'll see the just a second. I'll show you how Spark works. Master slave architecture. If you ever heard master slave architecture, right? So for example, if I'll say there is like a father. Okay, so father have 10 tasks and he has 4 sons, right? So what he will do, he will basically distribute the work. So let's suppose he will give three tasks to 2 sons, or two tasks to 3 sons, and rest 4 tasks to 1 son. Like that he will distribute. Okay, he'll say that please complete this task by EOD and submit me, and all son will do work independently. Okay, so he will process, all 4 sons will start working on that. Once the task is completed, at the end of the day, okay, they all come to the father and they will submit the work. So everything is done parallelly. Okay, not dependent to each other, everything is working parallelly. So this is called parallel processing. Understood, right? Okay, now come to the next thing, which is I said that Apache Spark is a unified computing engine, right? Computing engine. Now, what is computing engine actually? Okay. So, basically, Spark is limited to computing engine. First of all, okay. So, few things. Maybe few knows, few don't knows. Spark don't have their, uh, storage. Spark don't have their storage. This comes under everything is process compute, it do computing basically, and it does not store the data. Everything is done inside a RAM. Okay, so RAM is basically temporary. Once the processing is done, once the computing is done, okay, all data will gone. There is no storage when in Spark. Keep in mind, there is no storage in Spark. Okay. Then next is uh, Spark connect with multiple data sources. Okay, like S3 bucket is there, then HDFS is there, then our JDBC, ODBC servers are there, then Azure storage is there. Okay, so as Spark working in a distributed environment, okay, so distributed compute engine means distribute their work to the different workers. Just like father son example I have given right now. Okay. So which is nothing but CPUs and everything happen in RAM. Okay. On temporary basis. Once the process is done, data will go on. Right. So Spark is a open source framework. Anyone can use it. Anyone can distribute it. Uh, Along with that, it can handle large scale of data, large set of data. Okay, large set of data. Being a open source means that is like freely accessible. Okay, allowing developers and organization to customize it, just like our Python, right? Python is also open source. We can, customize it. We can customize our modules. We can also implement those modules, and anyone can, once will deploy that, and anyone can use worldwide that modules, right? Then distributed computing architecture, right? So Apache Spark having the distributed architecture. So pandas don't have this thing. Okay. So it will once the work is distributed, so it can handle the massive data set, big data. Basically, when come to big data, Spark is there. Okay. Then user friendly interface. So obviously Apache Spark offers an basic easy to use interface, which is simplify the complexity, handles the large scale of data, big data task, because it creates the jobs and all. Okay. Then it has API support. It support multiple languages like Scala is there, Java is there, Python is there. Okay, you can also write your queries in SQL as well. Okay, then along with that, most of the data engineer, data scientists use these platforms and Apache Spark whenever they are dealing with big data. Okay, in memory computing capabilities. So once the features of Apache Spark in memory. So I just told you that Spark don't have their own storage. Okay, Spark once work on the RAM, right? In memory processing. So it allows application to read and write data. Okay, along with that, with significantly speed, and there is like less time. Obviously speed will be there, then it will going to reduce the time for the data processing task, right? Then versatile data processing. So Apache Spark supports various data processing tasks, including batch processing is there, streaming is there. Okay, then machine learning is there. Okay, then extensive ecosystem. So Apache Spark's ecosystem includes several components such as Spark SQL is there, Spark Streaming is there, MLlib is there for machine learning, and GraphX is there for graph processing. Okay, so this extensive ecosystem enables user to tackle a wide range of data challenges. Okay, within a single platform. Okay. So the next is actually what problem do Spark solve? Okay. So first of all, anyone knows what is big data? Anyone knows what is big data? Okay. So big data. So basically, big data works on three V's. Okay. So first is velocity. Second is variety. And third is volume. Okay. So first, let's understand with volume. So, what do you think if you are getting 1 GB of data, 2 GB of data, or 10 TB of data? Does it call big data? Does it really call big data? No, no, a big no. Okay. So this basically depends on the velocity. Okay. So if 1 GB of data is coming, 2 GB of data is coming, 10 GB of data is coming. The question is how frequently it is coming. Okay, if one maybe per second is coming, or per hour is coming, or per minute is coming. Okay, so this is called big data if we know the frequency, we know the velocity, right? Right. So if we are getting 1 GB of data per second or per minute or per hour, so this will call big data. But we are saying that we are getting 10 TB of data at whole day. So that will not call the big data. Okay. Now come to the variety. Variety. So variety, so those who know SQL, they already know the type of data, variety of data. So there are three data basically: structured, right? Then semi-structure is there, and then unstructured is there. Fine. So I hope you understand the meaning of big data. Okay. So now previously we were working in the ETL. ETL. What it calls? Extract, transform, and load. Now that time data size was big, small, not that much of big. That was not a big data. So we were using this process called ELT. ELT. Okay. So first of all, we are extracting the data and we are transforming. We are holding that data somewhere. We are transforming and then we are loading to that their destination. Okay. Now we have a big data. We are doing multiple processings are there. We are doing applying parallel processings are there, right? So this above process, this ELT is happening in the data warehouse, right? Data warehouse. Now we have a data lakes are there. We have data lakes, right? So now we are using ELT. Why? Because we cannot transform big data together. First of all, what we will do, we will extract all data. Then we will load that data to our data lake. And then we will transform it. जैसे जैसे time मिलेगा, we will transform it. Understood? Now, what issue we had? Okay, we have we have basically two issues. First is storage, because big data is there, and the second was processing. If data size is big, so we cannot process all data together, and this issue will be like RAM and CPU will be exhaust. CPU will be exhaust. Heat distribution will be there. Okay. So basically, to handle this issue, we have a two options. To handle the big data, we have a two option. Handle big data. Two options are there. Okay. First approach is your monolithic approach. Okay. So what actually monolithic do? Okay. So there is one system. Okay. So all processing and storage will done in one system. Okay. So basically, vertical scaling, vertical scaling, then um, so what is vertical scaling? Okay, so basically this is your one system. Okay, now now previously it is okay. Then uh, we are getting more data. The data is increasing. Okay, now we will need uh, more disk, right? More disk. So what we will do? So we will add vertically every time. Okay, every time. So it will be work like in layering. Now the cost will be there again. The cost factor will be there. Like अभी हमने एक use किया, then we will use we have to add more RAM here. So we will change the disk. We will add here again the same thing. Okay. If then next is there will be issue of low availability. Okay. Now let's suppose if one layer fails here, what do you think? The entire system will fail, right? The entire system will fail, right? Again, the cost extensive is it will be expensive. Then vertical scaling will be there. Then low availability there. If one layer fails, everything the complete system will fail. This will be the issue. And we have the second approach. This is called distributed approach. Distributed approach. Okay. Now, what happen in distributed approach? Okay. So, first of all, so this is our systems. One system, second system, this is third system, right? And so on. So, if you need more system, you can add horizontally, one by one. Okay. If one system fails, let's suppose the system fails, but it will not going to affect this system and this system. Your data is secure because your work is distributed here like this way, right? Along with that, high availability will be there. Okay. The next thing will be, it will be economical. It will be economical because you have to add the system only. You have to add the system only because we don't need to use the storage now. We only need the system for the processing, right? Okay. So for solve this issue, we have a Apache Spark, which is the distributed approach. This one is what? For Apache Spark. Okay. Now, why Apache Spark? So, first of all, this can, um, connect with multiple databases. Like Oracle is there, Oracle is there, DB2 is there, Teradata is there, then SQL Server is there, MySQL is there. What happened? SQL is there, right? Then it can also handle multiple file types like CSV, Excel, then image, because nowadays data is coming in different forms, not in a single form. JSON, XML is there, right? So to handle this type of data, we need the Spark. Okay, we need the Spark. So yeah, this is about why we need the Spark. Now, for the distributed approach, for the distributed approach, we have two options are there again. For the distributed approach, we have two options. One is Hadoop and the second one is Spark. Okay. Now let's understand Hadoop versus Spark. So first, let's see the misconceptions. Okay. So I heard that Hadoop is database. Hadoop is database. But but this is not correct. Hadoop is what? Hadoop is a framework. Hadoop is a framework. Okay. Same for Spark as well. Same for Spark as well. Again, Spark is a framework. Spark is a framework. Spark is framework. Okay. Now, few people say like Spark is 100 times faster than Hadoop. Spark is 100 times faster than Hadoop. Again, it is not correct. Okay. It is not correct. It is, it is up to 100. Up to 100. Totally depend. Okay. Up to 100. And third is again same thing. Spark process the data in RAM, but Hadoop don't. Spark process the data, process the data in RAM, but Hadoop don't. But it is again not correct statement. Okay, it is not a correct statement. We'll see. We'll see this in the difference. Spark versus Hadoop. Okay. Okay. So yeah. So let's understand the difference between Hadoop and Spark. Oops. Hadoop versus Spark. Okay. So there are points are there. First is our parameter is performance. Okay, performance. So performance wise, Hadoop is slower than Spark. Slower. It is slower than Spark. Why? Because it writes the data back to disk and read again. How it works basically. Let's understand this. Okay. So this is basically your disk. Okay. We have data, right? Now what we will do, we will process this data this way. Okay. So this we are writing this data here first, reading it, we are writing here in the memory. Okay, then what it will do, it will going to write this thing again into the disk. This is your disk. Okay, and then same way again it will distribute it and then write to the disk. So this basically is going to be increase the time. So this is the reason it is slow. Okay, this is the reason it is slow. So we have a disk. We wrote the data here. We have a data here. We have distributed this data to the mappers. Mapper then again will going to write the data to the disk. Then disk will again going to distribute the data, work in between the mappers, and then it will going to write to the disk again. So this is the reason it is slow. Okay. Now come to the Spark. So Spark is obviously faster than the Hadoop, but not 100 times faster. Keep it in this point in mind. Okay. This totally depends. Okay. So this is for the Spark. So this is our disk again. Okay. So this data is there. It is going to be distribute the work between the executors. Okay. And this executor will going to write your data to the your RAM. That's it. So this much of process happen in the Spark. So that is why Spark is faster than Hadoop. Okay. The next parameter is batch streaming. Batch and streaming. Batch and streaming. Okay. So basically Hadoop is built for batch data processing. Hadoop is for the batch data processing. Batch data processing. Okay. And our Spark. So Spark is built for both batch and streaming, both. It can go with the streaming as well. It can go with the batch as well, right? Now, ease of use. The next parameter is ease of use. Okay. So basically, Hadoop is difficult to write the code in Hadoop, and because it is built on Hive, okay, which make it difficult. So for Hadoop, difficult to write code, difficult to use, okay, and for Spark, so basically in Spark, it is easy to write because it supports multiple languages. Okay. So, and also debugging is easy in Spark. Okay. Because also Apache Spark provide the low level and high level APIs are there. Okay. And it use multiple languages like Python is there, Scala is there. Okay. You can, R is there, even R is there. Then you can query there. So that's how it works. Okay. Now come to the security. Security. Okay. So basically, Hadoop uses the Kerberos authentication and ACL authorization. It uses Kerberos authentication and ACL authorization. Okay. And for the Spark doesn't have solid security features. Security features. Okay. So for this, it uses the HDFS storage, and from HDFS storage, it takes the ACL level control and use YARN for the Kerberos authentication in Spark. Okay. So it basically uses the third party feature for the security. Okay. So it uses the what? HDFS storage and get ACL level control. So it basically use the yarn. So using the yarn, it will get the Kerberos authentication. Okay. Now the next big feature is the fault tolerance. Okay. I hope the security feature is clear to all. Next is fault tolerance. Okay. So for the fault tolerance, okay. So basically Hadoop is having block of data and replication factors are there to handle the failure. Okay. So there is in Hadoop, block of factors are there, block of factor like block of data and replication factor to handle the failure, to handle the failure. So uh, multiple replication factor means multiple copies. So for example, we have data is 250 260 MB data we have. Okay. So we are going to distribute it between three distributors. A, B, and C are there. Okay. Now it basically works on nodes. Okay. So in node 1, we have distributed like A is there and C is there. In node 2, C is there and B is there. In node 3, A, B, C is there. That's how it is distributed, for example. Okay. Now, out of these three nodes, one node got failed. This node failed. Now, so if one worker will fail, then also it will work because we have distributed it. We have multiple replication factors are there. We have multiple copies are there. Okay, right? Now, next is for this Spark. For this Spark, so for this Spark, basically Spark uses the DAG fault tolerance. DAG fault tolerance. Okay. So DAG means directed acyclic graph. DAG means directed acyclic graph. So is the process will be distributed in this way. Process 1, process 2, process 3, and so on. Okay. Now, out of 3, let's suppose this process 2 has failed. Okay. So is Spark having feature retry is there? Okay. It will retry. Out of 3 retry, it will going to be, remember this, if after 3 retry it will not going to be execute, it still failed, then it we know that process 1 is executed successfully, right? So from the output from the process 1 we already have, so it will going to give this output again to process 2 and it will start again and it will success this time and it will go output to the process 3. Now this time if process 3 fails, the output of process 2 is still there. Okay. So it will take output again from process 2 and it will going to be execute like this way. So if one will fail, it will going to keep remember. Okay. If a process 3 fails, it will recreate the process 3 again because it is taking the input from the process 2 and process 2 is already success, right? So I hope this why we need a Spark is clear to all of you, right? Okay, second. So compute engine is clear to everyone. Compute engine is basically, you know, it basically work as a resource manager. Okay, we have one resource manager. We have node, again, the workers are there. It will going to distribute your work. Okay, it designed to execute basically distributed data processing tasks across the network. Okay, it allows the parallel processing of large data sets and optimize the resource uses and reducing the processing time. Okay, along with that, it manages the resource allocation for which resource how much memory should be there, which how much storage should be there, uh, and CPU effectively among with various tasks. Okay, this ensures that each task has the necessary resources to execute without the bottleneck. Okay, with the improved performance. Now, then there is a execution of tasks. So it is again responsible for executing the tasks that are a part of data processing workflows. Okay, then that engine handles the complexity of task execution, and it will make sure that tasks are completed successfully and efficiently. Okay, the next is scheduling the job. So while scheduling the job, compute engine is big thing. It determines the order when to schedule which job. It determines the timing, which task should be execute at which time. Also, it will help to optimize the workflow on the ideal time and maximize the throughput. Okay, then you can see these examples of compute engines are there. Spark is there, Hadoop is there, Flink is there, and there is a parallel processing. So everything I had mentioned in this PPT, and I had already shared that PPT. Anand has attached that GitHub link in the description already, so you can check out there. Okay. Computer cluster. So again, the computer cluster is a network of multiple computers or multiple nodes. Just now I had shown to you. Okay, this collaborate with a single system, and it allows the architecture to improve the performance and efficiency of the various tasks. It distributes the work equally and takes it back. Along with that, we can have multiple nodes are there based on our task, based on our data. Okay, then there is high performance computing. So whatever computing, whatever things will going to happen in the computer cluster, it will going to support. It is capable of handling the complex calculations and simulations. It also help in the essential field like scientific research is there, engineering, financial modeling. It helps there. Okay, then big data processing. So again, big data processing, it basically distribute the work equally and process it parallelly so that they can manage and analyze large data set efficiently. Okay, and making them evaluable for the businesses and organization. For the data scientists as well, they can use this data for the modeling and future predictions. Okay, now come to the advantages of Spark. Okay, so Spark basically offers the speed. Okay, then speed is like, okay, obviously it is working in the distributed environment. There is in-memory processing is happening. Again, there is the traditional desk-based system. So it is again increasing the your processing capabilities, right? It allows you to for the real data time processing. It helps in the batch processing. Along with that, streaming is there, so it makes your data processing faster. Okay, ease of use. So it supports multiple programming language. As I told you that Python is there, Java is there, Scala and R is there. Along with it, it also helps in the writing the SQL queries. So it is giving the flexibility. Okay, it is giving the flexibility. The interface is very easy to understand. You can simply, just like your, if you know basic Python, right? So you simply use this Databricks. There is a notebook. Again, the extension will be IPyNB only. The working will be the similar as our notebook, but the difference is there will be it will be like distribute work in the distributed environment. Computer clusters are there, right? Then fault tolerance feature is there. Okay, it will automatically recovering the lost computation without manual intervention. This feature ensures that data integrity should be there, reliability will be there, right? And it is again crucial for the applications requiring consistency for the data processing. Okay, Then scalability will be there, whether the single machine or across the large cluster. Okay, Spark scales effortlessly to handle varying the workload. It will distribute equally based on the data site. Okay, this adaptability makes it suitable for the all the project, which all size of data from a small data set to big data. Understood, right? Now come to the PySpark. Okay, so for the PySpark, just a second. Okay, so what is PySpark? So let's see Pi plus Spark. Okay, so it is basically PySpark is working on the Spark framework. Okay, this is again the API of Python, API for Apache Spark, which allows developers to handle the large data set using the Python programming language. So, Anand sir already told that the if you know Python, you will understand the PySpark. You need basic Python understanding. So, in our course, we have already attached our Python course as well with this PySpark course. So, if you are, you don't know about Python, that is okay. If you purchase this course, if you want to learn the PySpark, so there is a Python course is there. You can follow that course, and along parallelly you can follow this PySpark course. You will understand everything. Okay. Then in PySpark enables the data processing at large scale. It is designed to handle large data set across the distributed computing environments, making it ideal for big data applications. And it we can connect it from the multiple cloud engines, or along with that we can also connect it with our SQL servers as well. Okay, so there are multiple connectors it is providing. We can take as a source system from anything, and we can save our data to any destination. Then, along with that, PySpark having learning integration. Okay, with PySpark, user can apply machine learning algorithms using MLlib libraries there. This allows for the building and deploying the machine learning models directly within the Spark framework. Okay, then powerful libraries. So PySpark having powerful libraries such as Spark SQL, PySpark, Python for structured data processing. Then for machine learning, MLlib is there, right? For Spark streaming, for real-time data processing, it has the libraries which enhances the capability for the various data tasks, right? Then we can also follow the real-time data processing, right? Also, one more thing is there. I would like to add. We can process this data once our data processing is done. We can create the delta lake as well. You can save your data in form of delta tables in your S3 bucket or in your any Azure containers. You can use those, and you can save your data in form of tables without using any server, any SQL thing. You can fetch the data easily. So PySpark having inbuilt delta table feature is there. Okay, now I'll show you why we need PySpark over pandas when we in terms of big data. Okay, so you can see here I have shared the screen for the one of the median blog is there. So this is very very well written. So what is PySpark? We already know that PySpark is a library for Spark programming. Python library is there. It allows you to use the powerful and efficient data processing capabilities of Spark from within the Python programming language, right? PySpark provides a high level API for the distributed data processing. right? That can be used to perform common data analysis tasks such as filtering, aggregation, transformation of large data sets, right? Those who knows Python, they knows the pandas as well, right? So pandas is again a Python library which used for the data manipulation and analysis, right? It provides powerful data structures such as data frame and series are there that are designed to make it easy to work with structured data in Python, right? So with pandas you can perform a wide range of data analysis tasks such as filtering, aggregation and transformation of data. Same with PySpark. Now, what is difference between PySpark and Pandas? Pandas cannot work in the distributed environment. Okay, but PySpark is made up for the distributed environment. So the problem we were facing to the Pandas, PySpark has solved that problem. Both are similar, but there is a different execution and processing architecture. Okay, so let's see the key differences between PySpark and Pandas one by one. Okay, so PySpark is a library for working with large data sets in a distributed computing environment. In a distributed computing environment, while Pandas working with smaller tabular data set on a single machine, right? Again, the PySpark is a built on top of Apache Spark framework. I already mentioned this, and it uses the RDD datasets, which is called Resilient Data Distributed System datasets. Okay, we'll explain this later. This is again a topic. Okay, but Pandas uses the data frame as a data structure. Okay, I hope you got this point. There is difference between the data structure and the framework. Then PySpark is designed to handle data processing tasks that are not feasible with pandas due to the memory constraints. Okay, such as like iterative algorithms, machine learning on large data set, big data processing, right? PySpark again allows for the parallel processing of data while pandas doesn't. Okay, PySpark can read data from variety of sources, including Hadoop distributed file system HDFS, our S3 bucket, and our local system it can read, while Pandas having the limited reading data from local systems, right? Again, PySpark can be integrated with big data tools like Hadoop and Hive, while Pandas doesn't. Okay. PySpark is written in Scala and run on the JVM which is called Java Virtual Machine, while Pandas written in Python itself. Okay, so PySpark has a steeper learning curve than Pandas due to the additional concepts and technologies like distributed computing, RDDs, parallel processing, Spark SQL, Spark streaming, etc. So now how to decide which library should to use when, right? So first of all, size of data matters. Obviously, if we are working with big data, so we can go with PySpark. If we are handling small data sets, that is okay. So you can handle with Pandas. Okay. So PySpark is designed to handle large data sets that are not feasible to work with a single machine using the Pandas. So if you are having, big data, so you have to, use the PySpark because it works in the distributed environment. So it do parallel processing that will make it faster. The processing will be faster. So if you have data set that is too large to fit in your memory, okay, or you need to perform iterative or distributed computations, so PySpark is obviously a better choice. Okay. Then the complexity of task. So PySpark is a powerful tool for big data processing and allows you to perform a wide range of data processing tasks, such as live streaming, machine learning, graph processing, etc. So if you need to perform any of this task, PySpark is a better choice. Okay. If you want to handle the big complex data, so again, PySpark is a better choice. Now come to the learning curve. So PySpark has a steeper learning curve than Pandas as it requires knowledge of RDDs, resilience distributed data sets, and Spark SQL. If you are new to big data processing and want to get started quickly, Pandas is the better choice. If you know Pandas already and you want to, work with big data, obviously the time is for the big data. Right now, we are getting the lots of big data problems. So PySpark is there to solve these problems. Okay. So resource availability. So PySpark requires a cluster or distributed system because it works in the distributed environment. It basically, distribute the work and perform parallelly, do data processing parallelly. So you will need the ap- appropriate infrastructure and resources. Okay. So yeah, that is about the PySpark. I mean, Pandas versus PySpark. Okay. Now come to the Spark architecture. Okay. So anyone having any questions till now? You can ask. Anyone? Anand, are you there?
Yeah, Prachi, I'm there. I'm there. I'm seeing the YouTube chat also and LinkedIn also. Continue.
Yeah. Yeah. Okay. All right. So now come to the Spark architecture. Okay. So we will explore this, the topic I have already have mentioned here. So Spark architecture and applications, then how Spark it will work, how we will work with the Spark architecture, along with that cluster manager types and execution modes. Okay. Now you can see Apache Spark basically work in the master slave architecture. Okay. So that consists of driver which runs as a master node. Okay. And whenever we will get any work, so this will first go to the driver node, master node. Okay. And it will going to distribute the work among with the worker nodes. Okay. Then, so basically which runs as a master node, your driver node as a work as a master node, and many executor that run across as a worker node in the cluster. Okay. So Apache Spark can be used for batch processing and real-time processing both. So here I have given the components. You can see executor is there, task catch is there, worker node is there, cluster managers are there, right? This is driver program, means your master node, and Spark context. Okay. Now, before understanding the Spark architecture, let's understand the components. The the components I have mentioned here. Okay. So, what is the Spark driver? So, this basically responsible for coordinating with the execution of the Spark application. So, it is your master node. It runs the main function and creates the Spark context, which connects to the cluster managers. Okay, which connects to the cluster manager. Now, what is Spark executors? So, these are your worker nodes. Executor are your worker nodes, which are responsible for executing the task in the Spark application, which has given by the master node. They are launched on worker nodes and communicate with the driver program and cluster managers. Okay, so executor run tasks concurrently and store data in memory or disk for catching and intermediate the storage. All right. Now, what is cluster manager? So, cluster manager is responsible for allocating the resources and managing the cluster on which the Spark application runs, right? So, Spark supports various cluster managers like Hadoop is there, Apache Mesos is there, Yarn is there. Along with that, PySpark having their own standalone cluster manager. Okay. Now, Spark context. So, Spark context is the entry point of any Spark functionality. Okay, it represents the connection to a Spark cluster and can be used to create resilient distributed data sets, accumulators, and broadcast variable. Those who knows Pandas NumPy, they know what is broadcasting. Then Spark context is also a coordinate the execution of the task. Okay. Now come to the task. So task is the smallest unit of work in the Spark, which basically representing a unit of computation that can be performed on a single partition of any data. Okay. The driver program divides your master node is divide the Spark jobs into the task and assign them to the executor nodes for the execution, as you can see here. So this is your driver program. It means your master node. It is distributing the work. They are completing the work and they are giving it back to your driver program. Okay. So in between there is a cluster manager is there. Okay. What this cluster manager is doing. So this cluster manager is basically managing your resources, right? So there are multiple cluster managers are there, like Yarn is there, Hadoop is there, and then Spark Mesos is there. Okay. Now, come to the Spark architecture. Okay. When the driver program in the Spark architecture executes, it calls the real program of an application and creates the Spark context. Creates the Spark context. It calls the real program of an application. Okay. Spark context contains all the basic functions like you can say the Spark driver includes the several other components, including DAG. DAG, I had shown you how DAG works, directed acyclic graph. If one of the process fails, it will remember that we are getting the output from the previous node, so previous process. So it will going to connect with the previous process again. It will take the input and it will process again. Okay. So DAGs are scheduler, then task schedulers are there. Okay. Backend schedulers are there. Block managers are there, all of which are responsible for translating user written codes into the jobs that are actually executed on the cluster Spark driver. Now, Spark driver and Spark context collectively watch over the job execution within the cluster. I'll show you once we are going to execute the program, how it works, how it looks like. It is not about theory, it is about practical as well. Okay, you will see how jobs working here and how it works basically. Okay, now the cluster manager manages the execution of various jobs in the cluster. Okay. Spark driver works in the conjunction with the cluster manager to control the execution of various other jobs. Okay. So the cluster manager does the task of the allocating the resources for the job. So once the resource got allocated, your job will be broken down into smaller jobs which are then distributed to the different worker nodes, and Spark driver will run and going to control the execution, right? Many worker nodes can be used to process the RDDs. As it is working in the distributed environment, it will distribute the work and then it will going to give you the output to your worker node. I mean, sorry, your not your worker node, your master node, that we have done this work. You can keep it and you can submit it by your Spark submit command, right? Then Spark context receive the task information from the cluster manager. It enqueues to an worker node. Now, one question is there: what if you have distributed the work, that worker node is not available? What you will do in that case? How the task or jobs will be distributed in that case? So for that, it will be, wait in the queue, that once that resource is available, it will going to allocate that resource automatically once this is done. Just like um in MNCs, if you are working in MNC, so there the bench process is there. Okay, so once you come to the bench, you are available to allocate any project, right? So once they will see you on bench, they will provide your information within the organization that this person is on bench. The skill set of this person is this. So based on that, they will allocate you the new projects. Okay, till then, if you are not on available, or maybe that particular requirement of their project is available, but the person is not available based on their requirement, so that particular thing will be in queue. So maybe they will hire a new person, so we can scale up our cluster, or maybe they will wait in the queue and complete your project. Once you will be available on bench, they will come to you, they will allocate you the project, and you will start working on that. Same will be work here. Okay, now there are two main abstraction of Apache Spark. Okay, so RDD is there. So RDD is immutable. So Apache Spark has a well-defined layer architecture that is designed in two main abstraction, DAG and RDDs. Okay, so RDD is immutable. RDD is immutable. So fundamental collection of elements or items that can be operated on many devices. On many devices. Okay, on the same time. So Spark parallel processing will be there. Each dataset in an RDD can be divided into logical portions, which are then executed on different nodes of a cluster. Understood. then then come to this directed acyclic graph, DAG. Okay, so what DAG is doing? DAG is scheduling the layer of the Apache Spark architecture, which portion or which notebook should run first, which process should run first. So first, if we are doing ETL process or ELT process, we will extract the data first from any cloud platform or anywhere. Then once the data is extracted, we will transform it, or we will load it first and then we'll transform it. Okay, so based on this, you have to schedule it. Okay, and this is basically stage oriented scheduling compared to map reduce, which creates a graph in two stages, map and reduce. So if you have taken my course of Python, there we have already covered this map and reduce thing. Map and reduce function, filter function, we already covered. So once this is done, Apache Spark can create a DAX that are contain many stages. It work in stages. Which stage should schedule first, then which stage should schedule second, like that way. Okay. Now come to the cluster manager type. So Apache Spark currently supports several cluster managers. So standalone cluster is there. So a simple cluster manager included with Spark that makes it easy to set up a cluster. Okay. Then Apache Mesos is there, a general cluster manager that can also run Hadoop, MapReduce, and service applications. Okay. Hadoop Yarn is there. So the resource manager in Hadoop 2. This Yarn is the resource manager in Hadoop 2. Then Kubernetes is there. This is again an open source system for automating the deployment. Okay, so this is scaling the management of containerized the application. So basically, once you will Dockerize your application, you create the image, you push to some registry like ECR registry or any other registry. You will simply push it. Once this is done, you can use the Kubernetes to deploy it, because Kubernetes is again a open source system, so it is used for the deployment of your containerized applications. Okay, execution modes. So cluster mode are there, client mode are there, local mode is there. Okay, so let's understand one by one. So cluster mode is probably the most common way of running the Spark application. Okay, most common way of running the Spark application, the cluster mode. Okay, so in cluster mode, we basically submit a pre-compiled jars, Python script or R script to a cluster manager. So there are we have to we have to submit the pre-compiled jars in our cluster mode. Okay, so the cluster manager then launches the driver process on a worker node inside the cluster, and in addition to that, the executor will process. This means that cluster manager is responsible for maintaining all Spark application related to this particular process. That's how cluster mode works. So in cluster mode application, your cluster manager will be responsible for maintaining all your Spark application related processes. Okay. Then client mode. So this is nearly same to the cluster mode. The difference is that the Spark driver remains on the client machine that submitted the application. This means that client machine is responsible for maintaining the Spark driver process. Okay, and the cluster manager maintain the executor. Here cluster manager work as a maintainer. Okay, and the client machine is responsible for maintaining the Spark driver process. Okay, then there is a local mode. So again, local mode is a significant departure from the previous two modes, which is client mode and the cluster mode. Okay, so it runs the entire Spark application on single machine. It can achieve parallelism through the thread on that single machine. This is a common way to learn Spark, test your application, or experiments iteratively with local development. So basically, we are not going to use this local mode. We are basically using the directly our Databricks. So yeah. So that is about the Spark architecture. So is there any difficulty, any doubt with the Spark architecture? You can ask in the chat.
Prachi, they're asking about RDD. Can you throw some light? What does RDD means? Satish is asking.
Yeah.
Yeah.
Yes, yes. So RDD means your if you know pandas. So on pandas we are working in the data frames, right? We are working in the data frames. So RDD again same. So this is resilience distributed data sets. So just focus on the distributed work. So this is basically working as the you know same as your data frames, just in the distributed environment. Understood, right? Yes. Any other thing? You can ask in the chat. Anything other than that? I hope you are clear. So for this RDD, we'll take the complete class. Just I wanted to give you a little light about how RDD is like work.
Yeah, I
All
think
right.
it's clear. Yeah, we can proceed, Prachi.
All right. So I would like to show you the Databricks platform. So for our course, we are going to use the Databricks Community Edition. Databricks Community Edition. So if you are right now, your system is open, you can create your account right away. I already have that. I just wanted to show you. If you have any doubt with this, you can ask me later, or you can ask me in the chat as well. Okay. So I'm logging in. So we have to give here the mail ID, and that's it. We will get the verification code. Yeah, that's how you can, log in. And so yes, this is the UI of your Databricks. Okay. So from here I'll show you one by one. So here you can, create your notebook. You can upload your any data set as well. So if you are working with any CSV, any file, any Excel file or anything, you can, upload here, right? The notebook you can create from here like this way. Okay. And one more thing is there. You can see the cluster is there, right? So I already shown you what is the meaning of cluster. You can create it like this way. Okay.
Prachi, do we have to
Yes.
pay anything for any code which we run it? Like we have to do it
No.
on the phone, nothing like that.
So we are using community version. So
Hmm.
here we don't have to pay any single thing.
Oh, great.
Because here I'll show you the cons of this platform right now. Like we are not paying anything. So
Just they need to create an account. That's it. No credit card, nothing is
that's
required for this.
no, nothing is there.
Okay, cool.
So yeah, because we will not able to use this workflow process, which is called scheduling. Okay.
Mhm.
So if you want to schedule it, so you have to subscribe it. That's
Okay.
it.
Okay.
Now there is compute is there. Okay. So from here you have to create the compute. Okay. So compute, I already told you the meaning of compute. We will basically, you know, create the different computers, like the core of computers. How many cores you want? One core, two core. Okay. So for free version, we have only this much of this. So yeah, this is the free version. Okay, once you will create, so free, you can see instance 15 GB memory as a community edition user. Your compute will automatically terminate after an ideal period of 1 or 2 hours. So if you have started, you have created your compute. Okay, if you are not working and you have kept it idle. Okay, so after 1 hour, it will got terminate automatically. Okay, so that is why we are not getting any cost for this, because the your instance is automatically terminating. Okay. Once I'll create the compute here. So it will take some time to create. So I'm requesting everyone to create your Databricks Community Edition account. I'll be happy to help. If you find any difficulty, just ping us in the chat. I'll show you, or we will reply, definitely reply over there. And whatever we have done today, if you know this much of, theoretical part, so you are, crack any interview in terms of theoretical question, how Spark works, how it is computed, and what is the architecture, what is the difference between the Hadoop and Spark. That is very, very important questions we have completed here. Along with that, we will provide all the interview perspective materials to you inside this course. So yes, my cluster is created. Okay. Right now you can see notebook is 0 because I haven't given this cluster, I haven't assigned this cluster to any of the notebook as of now. So once I will do this, it will be going to take it, and you will see you will see here the one notebook is associate. So number of notebook will be 1. Then come to the libraries. So here you can install any libraries if you required for your system or your application. Okay. Here whatever will be there, uh, event log will be going to generate. So you can see cluster is running, driver is healthy, and creating. So event log, whatever event is happening, it is going to be generated here. You can see Spark UI is here. So right now we haven't done anything, no job we have run. So you can see there is nothing. Okay. Then driver logs will be there. All driver logs, whatever you will provide. Okay. You will get everything here this way, the error and everything. This is Spark Compute UI master. You can see, right? There is catalog option is there. You can see here the options.
So everyone, please create this Databricks account, and anytime you are having any issues, we can discuss it. Since Prachi is explaining you each and every type, so utilize this time in creating this account. It's hardly 1 minute. Okay,
Yes.
so do it.
So create the table here. So if you want to upload any data set here, you can upload it. I'll show you to upload. If you want to upload, for example, this is test I'm uploading. Can see here. Can you see this? The file is uploaded here, and this is the path. This is the path. Okay. Any other data set you want to upload, you can upload this way. All right. You can now come to the recent one. Okay. So whatever you have created just now, you will see here. Workspace is there. Okay. So in a workspace, you will get this way, shared and users. Okay. So someone has shared their workspace with you. You can see here. Okay. If you have created the users here, you will see here you have added user here. If you want to share your user thing, you can add their user ID here, right? Along with that, these are my workspaces. Okay. So I have created one example file is there for your reference. Okay. And you can create anything. ML flow experiment, you can create any folder wise. You can give anything, like if you are creating working on any ETL pipeline, you can based on your requirement, you can create the folder structure just like your local system. Whatever you are creating in local system, you can create here directly. You can test it. Okay. And this is home. So all your folders and everything you will get here. Understood? Any doubts till here? Anyone? Have you created your account? Have you created your account? Have you created your account? Yes, no. Give reply in the chat. Have you tried? Are you facing any difficulty to creating a Databricks account? kindly follow the same approach and you can create it. There is no like nothing is there to be very tough thing. Okay. Once this is done, once this is done, okay, I'll show you the notebook. All right. So here I have created the pandas data frame. And before that, if you can see here, if you can see here, the cluster is terminated due to inactivity. So terminated after 60 minutes automatically, right? So now this cluster is created by me right now. So I'll simply use this. I'll connect. You can see once the cluster is connected, you will see here the green symbol, right? Once this is done, if you want to run all your files together, you can run it or you can go through one by one. Okay. So here I have created the data frame using the pandas. Okay. So I have uploaded one, my data is there. Okay. So I tried to read it through the pandas, but I had told you that pandas have, can read from minimum things like minimum connectors are there to read the files from any other platforms. So this is basically HDFS platform is there. I have uploaded the data there. So it is not able to read it. It is saying that no data found. Okay. So you can see the file is already there, but pandas is not able to read it. Uh, yeah, this is the file I had used. This is the path. So can see here. So file not found. The file is already there, but it is saying file not found. But same if I'll do with PySpark, it will going to be execute. So same data frame I have created. So for the library, we will use PySpark.sql import Spark session. So while creating any, Spark, using Spark, we have to create the Spark session. Spark session using the app name and get or create. Okay. So we will use this Spark always while reading or creating any data frames, anything. Okay. So you can see here, I have created the data. I have this data. Okay. Columns are this. Now I will create my data frame here and I'll show them. So there are two commands for show, display is there and show is there. So I'll show you display as well.
It's almost on similar line, Prachi, right? As we do it in
Yes.
pandas, same only. So it's very easy to
Yes.
understand. That's why I said if they have a basic
Absolutely.
understanding of pandas and NumPy, it's fine for them.
Yes, exactly. All right. So you can see here your data frame. And here is your data frame. Now see the difference between how it looks. The look wise is very different. This is more readable. You can see the data type. It is showing same as your, um, date. If you know, in any of the database, there it is showing the type of data should be there, right? Any of the data. I think so, Anand. If you remember anything, any database, like if you
No,
have created any table,
Snowflake doesn't show.
yes,
Snowflake has to see the definition. Only in Power Query Editor you'll have able to get to know this. But Spark shows
yeah,
you this. This is really great.
yeah,
Yeah.
yeah, yeah. So like this way it works. Okay. Now, if you want to read, your data from, I have uploaded here. I had shown you how to upload the data. I had uploaded one file there, and I am trying to read it. Okay. So once I'll execute this, I am reading right now the CSV file. So have you see this, the Spark jobs are creating? Can see here? jobs are creating, right? So once I'll click in this view, you can see here the status, the submission time, how much time it has taken to, run execution, and how much SQL queries are associated there. Everything it is going to be shown. Along with that, DAG visualization, it is scanning the test, and then it is creating the stages, and then it is executing. Everything you will be. Right now, it is very small query. S- For this as well, it is creating this way. So just imagine if you are working on the big data, big, big thing. So it is visualization wise. If you want to see, visualize it, how it is working, once you will see it, it will be very interesting, very, 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 like a visualization wise, it will be very pretty. So see, this is scanning the text, then file is scan RDD, you can see here, right? So we are reading the CSV file, CSV at native method. Okay, then it is mapping the partition of RDD, you can see here. Then it is mapping the partition of RDD 14. It is creating actually stages. You can see here, everything is there. If you will click one of them, the data is changing here. If you will see select all, everything will be there. Duration, GC time, result serialization time, getting result time, scheduler delay is there. If execution memory will be there, everything it will going to be visualized. If you perform any aggregation, you will get it here. Everything. Okay. And at the end, directly it is also showing your the data type. String is there, GDP, long, happiness index, double. Okay. So let's display this. Or along with that, it is similarly working as the, your Jupyter notebook, because while running, we are using two keys, enter and shift. And for, creating the new cell, adding the new cell, we are using escape plus B. So it is working similarly. Okay. So df dot display and see the data is there, and how beautifully it has, showing the data type directly, what type of data we have, everything it is showing. Here is the filter option is there, you can see data profile, you can add here data frame, use display data frame instant. Then you can add visualization like this way. Lots of option directly is there. So this way you can, display. See here, Australia, Canada, China, and everything is mentioned here. Happiness index wise, it has created. And you can also display side panel selection data side wise. So yeah, that is how it is working. So let's see the for pandas. For pandas, um, so for pandas, you are going to write this way. The syntax will be like this for this for filtering, right? For filtering. For your PySpark, you can see this display. df.filter directly, and then you will going to say that I need those data sets which have happiness index is greater than 6. Similarly, your SQL syntaxes, right? Yeah. So this is about this. And if you want to publish your notebook, right? So you can do this way. So anyone can view your notebook. So once you will do this, it will going to publish it. So if you are working on any project which you want to make it publicly, you can publish it from directly. Okay. You can create variables here directly. You can see what variable you are using in your system, in your, in your notebook. You can see everything there. Version history will be there. If you have done anything, you will be able to see the version history, last execution, everything. If it is failed, it is success, whatever it is, it will going to keep each and everything. If you have deleted any cell as well, that is again it will going to be keep it as a version history. Yeah, any question on this? Any question, anyone? Any question, guys? Okay, fine. Now, yeah, now you can see the component of Spark. Okay. So basically, Spark is around the Spark streaming, Spark SQL, ML graphics. There are lots of, but we are basically focusing on this four, right? Spark core is there. Okay. Now, now come to the Spark streaming. So how Spark streaming works, what it is actually. So Spark streaming enables the processing and analyzing the real-time streaming data. Okay. Now, what do you understand by real-time data? So if you are using Zomato, or you are using Google Maps, or you are using Swiggy, or Zepto is there, right? So these all are generating the real-time data sets, right? So it ingests data in mini batches and perform the parallel processing. It ingests the data in mini batches and perform the parallel processing on the live data stream. Okay. So Spark streaming integrates with the other Spark components. It is also allowing the seamless integration of batch and real-time processing. Okay. So you can also perform the batch processing. You can also perform the real-time processing. Both you can do. Right. Now there is the option of Spark SQL. So yeah, here from here, you can choose the language. From here, you can choose the language. You can see Python is there, SQL is there, Scala is there, R is there, right? So you can perform any of this four by the time. And one more thing is there, in single notebook, you can use it. If let's suppose right now I have used Python, now I want to query something. So I will change it by default language. Now it is using the SQL. If I'll write any SQL query here, it will going to be execute. Understood? All right. Now, Spark SQL is again module on the Spark that provides a programming interface for querying the structured and semi-structured data using the SQL, Hive SQL, or data frame API, right? It enables the seamless integration with other Spark components and supports the various data sources, including Parquet, JSON, Hive, JDBC, ODBC, right? Your cloud sources like your S3 bucket should be there. You can connect with your Azure containers, and you can also connect with Google Clouds, right? Then next component is your machine learning library, which is MLlib. So again, MLlib is a Spark scalable machine learning library. It offers a wide range of algorithms, okay, and utilize the classification, regression, and clustering methods, okay. And there is graph processing also there. So Spark having the GraphX is a graph processing library that provides a API for graph computation and analysis. Okay. Now you can see the common use cases of Spark. So fraud detection. So obviously Spark works with the real-time data processing, right? So fraud detection again. Then recommendation systems. So Spark works with the machine learning capabilities and distributed computing enablement, distributed computing engines, which is work with the recommendation system, and by analyzing the user's behavior and preferences, it will recommend it. Then predictive analytics will be there. So Spark's machine learning algorithm and in-memory processing are valuable for predicting the analysis, right? So yeah, that is about everything about Spark. Okay, and I'm good with this. So anything you want ask, you can connect me over the over the LinkedIn, and you can also connect with Anand as well for this course for more details about the course. Obviously, you can share this video with your fellow friends who are needy for this course, who are looking for the change their streams from data analyst to data engineering, or those who want to start their career as a data engineer.
Yeah.
So yeah, thank you so much. Over
One
to you, Anand.
question, Prachi, is that Matrika is asking, is there orchestration option also available?
So just like Python, we are, orchestration. We are doing orchestration, transformation, everything using the Python. So that's how you can, here as well, we have to, utilize our codes. That is the thing. Because you are thinking that PySpark is different, but PySpark is a part of Python only. So that is why we are saying that if you have a basic Python understanding, you will easily understand the PySpark.
Yeah, it's almost on similar line, and as I can see clearly. One question which
Yeah.
I had personally, do we need to install anything like Python? We need to configure it. Can we run the PySpark code on VS Studio or Anaconda or anywhere, or only on the cloud?
So along if I'll say so, if we want to configure this in our local system, so we will require lots of configuration. It is not about VS Code. It is not about
Mm-hmm.
uh your notebooks. Okay,
Mm-hmm.
we can use it, but for that we will require lots of jars like Hadoop. We will require
Oh, external
it
jars we
works
need to add it into
JVM.
our environment
Yes,
variables.
yes,
Okay, so better
yes,
to, that's why we have brought this course
yeah,
on the cloud. It's
yes,
better to do it in the cloud
absolutely,
only, so that
yes,
this entire technicality is done.
yeah.
Anyone have
Or
any
the
question?
second option is also there.
Mm-hmm.
So if you are using Docker, right?
Mm-hmm.
So you can use virtual Docker images. So if you can simply write your code in VS Code, you can use any image of PySpark, because there are inbuilt images for the Docker. So you can uh, publish. I mean. Run those codes in your image. You can create, you can
Mm-hmm.
containerize your code, and you
Mm-hmm.
can execute it. Then also you will get the output.
Okay, looks
Yeah.
good. Okay. So guys, go ahead and enroll in this course. We have kick-started from today. So next class will be next Saturday, 12 p.m. in the afternoon till 2 p.m. Prachi will be taking care of the entire PySpark, and we'll have some other expert session also in this. Right? Few expert sessions are there down the line. You get the entire Python course in this embedded, right? Whatever we have, Prachi has taken delivered from the past few days in the Python. So entire 3 month or 4 month of Python course is embedded absolutely free of cost in this. So no need to go for separate Python course. So if you are starting your Python journey, you can start your PySpark journey also in parallel, right? So thanks, Prachi. That's all from our side. So feel free to reach out to Prachi or to me, or go on Analytics with Anand in the course section on the website, and you can browse all the courses. And do subscribe to our channel, right? Bye, guys. Have a great,
Bye.
lovely weekend. See you sometime next.
Yeah. Good day, guys.
Bye.
Bye bye. Thank you.